Hello Big Reds and welcome back to Schoology videos. We're on Unit 3, Learning Target 10. I can construct circumcenters, incenters, and centroids in an acute, right, and obtuse triangles using geometry software or a compass and a straight edge. For success criteria, you need to turn in these constructions as a formative assessment. All right, so there's not going to be no formative assessment afterwards. The formative assessment is actually turning these in. I want to make sure you've constructed them correctly. All right? So first of all, we're going to start off with drawing a triangle. All right, you can draw. I'm going to zoom this out so you can see about how big to draw the triangle. I don't want it too big, so things will get off the paper. And I don't want it too small, because then it's hard to do all these constructions, right? Okay, so first of all, we'll start off with the circumcenter. Okay, circumcenter is an important point in the triangle, and it's formed by constructing the perpendicular bisectors of all the sides. Okay, so if you remember perpendicular bisectors, they looked a little bit like a fish. So I'm going to start again with the center of your compass. Put it right on, I'll zoom this in just a little bit more now. Put the center of your compass right on one of the vertices of the triangle. Put your finger there, and then pick a point that's over halfway. I'm going to put mine on where it says 3R, and that may or may not work for your triangle. But I'm going to make an arc up and down. Okay, and then I'm going to do the same thing over here, this construction. Put a mark down and up. And I'm going to connect those points. And now that's my perpendicular bisector. Okay, so everything on the perpendicular bisector is the same distance from this point as it is to this point. And that's important for what we'll talk about with the circumcenter. Okay, now I want you to turn your paper, and I want you to make another perpendicular bisector right here. Okay, so I'm going to do this one. Let's see if I can use a different color here so you can see it a little bit better. I don't know if this will fit through the hole or not, but put center of this compass right on that vertex. And I'm going to use that same mark I used for the other ones. Oh, looks like I can't do that. Maybe if I sharpen my pencil really quick, I can do that. So, try this. There we go. See, I made it nice and blue for you. Then put the center of the compass right here and draw another arc out here. And I'm going to connect the intersection point of this compass and this compass together. I'm sorry, this arc and this arc, the intersection points of the arcs. You can see this is a perpendicular bisector of this side. And finally, go over here, and I'm going to do another perpendicular bisector. I'll make this one blue as well. And I'm going to connect the intersection of the arcs. Okay, you can see you have three perpendicular bisectors that meet in the center, and that is called the circumcenter. So now, what's special about the circumcenter is the circumcenter, because it's on the perpendicular bisectors, is equidistant from the vertices. Okay, so if I have A, B, and C, and this is point D, the circumcenter is point D, A to D is equal measure from B to D is equal measure from C to D. That's what's special about that circumcenter. Okay, let's try another one. Let's try the in-center next. Draw another medium-sized triangle. Probably about the same size we used before is fine. Okay, so I'm going to label this, I'm not going to label it quite yet. Now the in-center is where all the angle bisectors intersect. So if you remember what angle bisectors look like, first thing you do, put the center of your compass right on one of the vertices, again, of the triangle. And I'm just going to draw a small arc. Just going to put my pen right here. Okay, and I'm going to do that for all 3 vertices to kind of speed this up a little bit. Okay, now after that, I'm going to draw an arc from each of these points. A point right here, where the arc intersects that side, and a point right here. Start from this point, put the center of my compass right on that point, put my finger there, and I'm just going to choose something that goes over halfway, doesn't matter. So I'll start with, I'm going to use this where it says 1.5 R. Kind of right below that. Make sure you use the same hole each time. So you put the center of your compass here and draw another arc. Now if you notice those arcs intersect right in the middle, I'm going to connect the intersection point of these new arcs with my vertex of the triangle. And that's an angle bisector. Angle bisector, just to let you know, is equidistant from the sides of the triangle. So any point on this angle bisector is the same distance from this side as it is from this side. That's what makes it an angle bisector. That's going to come into play later on. Okay, I'm going to do the same thing over here. Put 2 more points on this arc. Put the center of my compass here, and put my pen in the same holes I used before. Go to both of these points. And again, I have 2 intersecting arcs. I use my straight edge, connect that point with the vertex of my triangle. Okay, you can see those angle bisectors intersect here so far. And let's start from this arc right here. Put dots each of those points. And make an arc. Make another arc here. And I'm going to connect the point where those arcs intersect with the vertex of the triangle again. So basically I just made 3 angle bisectors. Must be off by just a touch here. They should all intersect in the same spot, just like the circumcenters did. And this spot where they intersect is called the in-center. The in-center. The in-center is where all the angle bisectors intersect. They're coincident right here at the in-center. Now, what's also special about this in-center is because all the angle bisectors are equidistant from the sides of the triangle, in center is also equidistant from the sides of the triangle. So if I was to extend these angle bisectors I made out just a little farther so they intersected the sides, I made a point here, we'll call this A. Made a point here, call this B. Oh, I see where my mistake was, maybe. Supposed to connect it. There we go, that's a little bit better. C, this is point D. Okay, so we said the in-center is equidistant from the sides of the triangle. So AD is going to be equal to BD, which is going to be equal to CD. And notice the difference between this one. The in-center is equidistant from the sides to our circumcenter, which was equidistant from the vertices or the angles. Okay, two different things. All right, last one. Last one. This is the coolest one, my thing. The coolest one. So, zoom out, draw yourselves a triangle, and I'm going to draw myself a different unique shaped triangle this time. Just make it not very equilateral, make it definitely a scalene triangle. So we have three different sides, okay? We'll call this triangle A, B, C. All right, now, to get the centroid, we have to find the midpoints of each of the sides. So to get the midpoints, I'm going to have to use my compass again, construct a perpendicular bisector. Cool. So start with the center of your compass right at B. And I'm going to use, see, for this one I'm going to use different than the other one. So this one I'm going to use this 3.1416 hole here. Use the same hole. When I go over to C here, and what I'm going to do is I'm going to connect those two intersection points on the arcs, and I'm going to extend it out a little farther. Extend it out into the triangle. All right, now do the same thing with, and I'm going to zoom out a little bit for this, with A and B. Center my compass on A. Now I want to get a point farther out, so make sure it goes halfway. So I'm going to choose on mine, where this arrow is out here past the 3. And then put the center of my compass on B. And I'm going to connect those intersection points. Okay, you can see those points are connecting, intersecting right there. Now let's do one more. Let's do from this side, do the same type of thing. Basically, you're doing the same thing to both sides. And they connect here, and this is called the centroid. Now, the cool thing about the centroid is what I'm about to show you. So I want you to take a pair of scissors. If Mr. Official didn't hand them out to you, make sure you ask him for them at this time. Pair of scissors. I'm going to cut out this triangle. All right, now I have this triangle all cut out with my centroid. Okay, now I'll show you the cool thing about a centroid. A centroid, can you see me? I'm right here. What I want you to do is on your centroid, I'd like you to put your pen or pencil right on that centroid. And if you did it correctly, key word is if you did it correctly. If I get rid of some of this static electricity here. Should balance just like that. So that centroid is also your center of mass, center of gravity. So when you construct a centroid, that's going to be the point that you can put your pencil on, and it'll balance just like this. Pretty cool, huh? If you did it correctly, anyway. All right, so again, you're going to be turning in to Mr. Fischel this triangle that has your centroid on it, page that has your circumcenter, and the page that has your incenter of the triangle. These are three very important points, and I showed you kind of the neat things about them. Just to recap, circumcenter is equidistant. It's formed by the perpendicular bisectors. It's equidistant from the vertices of the triangle. The incenter is formed by the angle bisectors, is equidistant from the sides of the triangle. And the centroid, which happens to be center of gravity. So, thanks for listening, and go Big Reds.